Here we are, lesson 6.2.3, continuation from what we did in class. Get a quick look here. If you didn't write anything down from class, you should certainly push pause, and you can get a closer look at some of the stuff that we covered. You should have your own notes, but if not, here they are from today's lesson, especially focusing on the equation for amplitude, equation for vertical shift, and then your period and frequency are both related. PB equals 2 pi. Remember how we started the problem. We listed what we knew, what information was given, information given. Intuitively, we determined the next minimum point from the information given. We plotted the points that we knew. That helped us determine the period, 12 hours. Helped us determine that we're going to use negative cosine graph. We could have used many other options, but that was the most convenient because that's what we were given. From that point, we determined all the information necessary to answer our equation, and then finally we answered 2 parts of the problem once we had our equation written. I'm going to demonstrate a second problem here, 6-93, Lamage. Okay. Again, this should be in your book if you can't see the board, if you can't see it from your home computer. Otherwise, we're going to go ahead and get started. Lamage rode his bike over a piece of gum. Lamage continued riding his bike at a constant rate. At time t equals 1.25 seconds, the gum was at a maximum height above the ground. And 1 second later, the gum was at a minimum. If the wheel diameter is 68 centimeters, find a trigonometric equation that will find the height of the gum in centimeters at any time t. So what we first need to do, just like we did last time, is start thinking about a picture and what information we have given to us. So in this particular problem, we see that at 1.25 seconds, the gum was at a maximum height. Okay, so we know max, okay, and that is at 1.25 seconds. Alright, 1 second later, the gum was at a minimum. So the minimum happened 1 second after that, which would be 2.25 seconds. Now what were those heights off the ground? Well, the wheel diameter was 68 centimeters. So think about a wheel. Here's the piece of gum. That's the minimum. The diameter is 68 centimeters. So obviously the minimum of the bike tire would be when it's touching the ground. So the minimum is at 0. The maximum is at 68. So we can go ahead and start plotting some of those points. So however you're labeling your x-axis, I would probably count actually by the units that they're giving us here. So let's say maybe every 4 blocks is 1 second. Why would we do that? Well, mainly because we have the 0.25. We have quarter seconds involved in this problem. It'll make our lives easier. Like Danny said, it's like cheating. Now 0 is going to be our min. 68 is going to be our max. So at 1.25 seconds, we were at a maximum. 1 second later, which is 2.25 seconds, we were at a minimum. So how many seconds later is the next maximum going to be? The next maximum will occur 1 more second later. It takes 1 second to go half a lap. So 1 second to go from here to here. And it's going to take another whole second to get back to the top. So 3.25 seconds. And we'll be back at 68. So 3.25 back up to 68, and that gives us our curve. So we're beginning here, if we're only using our given information, we're beginning with the maximum. So the first question is, what trig function begins at a maximum? If you say cosine, you are correct. So everything we do will be in terms of cosine. Now we got to figure out amplitude, frequency, horizontal shift, vertical shift, and the period. Of all of those, there should be one that's easiest. That should be the period. It took 2 seconds to go from beginning to n. Okay? We have an equation for amplitude. That would be your maximum plus your minimum, or excuse me, maximum minus the minimum divided by 2. So your amplitude is going to be 32. We have an equation for frequency, PV equals 2 pi. So if our period is 2, the only way that could be true is if our frequency is pi. So frequency is pi. Our horizontal shift is whatever we need to do to get from the y-axis to our first point, in this case 1.25 seconds. And last, our vertical shift is our max plus our min divided by 2. We're averaging them. It happens to be the same as the amplitude in this problem. That will not always be the case, but for this particular problem, that is the way what we have. So here we go. Y equals 32 cosine of pi x minus 1.25 plus 32 is our equation. Now we didn't have to use positive cosine. We could have used negative cosine, went backwards 1 second, and we would have been back to a minimum at 0. So there, if it was negative cosine, our horizontal shift would have been 0.25. We could have used sine, but we would need to determine the halfway point between these two, which would be right here. So if we wanted to use sine, it'd be halfway between 0.25 and 1.25, which in this case is 0.75, would be positive sine. So you have many options here. I chose the easiest because it's using all given information, which was the initial value of a maximum. So to find the height of the gum, so we have the equation. Now we can answer these questions, A and B. Find the height of the gum when Lamage gets to the corner at 15.6 seconds, assuming it maintains a constant speed. For that particular problem, you want to substitute 15.6 into our original equation. So y equals 32 cosine pi x, or excuse me, 15.6 minus 1.25 plus 32. Substitute that into your calculator and make sure your calculator mode is in radians. If our calculator is in radians and we do that calculation, we should end up with, give me 1 second here, 46.5, and we're talking about a height, 46.5, and I'm looking for label centimeters. So 46.5 centimeters will be where the gum is. So you figure 68 halfway up is 34. So 46 is somewhere in here. Find the first and second time the gum reaches a height of 12 centimeters while Lamage is running at a constant rate. So if that's 68, 12 centimeters is going to be down here somewhere. So we're looking at the first and second time that the gum reaches a height of 12 centimeters. Alright, I'm going to just take my equation here and I'm going to go ahead and move to the next page. And I'm waiting here, we're kind of slow, not responding.